Hello everybody, how are you today? Good, good. Today we will discuss conservation of energy. Okay? First of all, making an outline is a good idea because it makes everything easier. So, our outline. Firstly, I will explain our motivation. This is about what we learn. Okay. Second one, definitions of kinetic energy and potential energy. And thirdly, I will give an example. And lastly, result and discussion. Okay? I believe that everybody is familiar with the concept of energy. You know, an idea what is energy? Okay, let me explain. There are two types of energy. Okay, the first one is kinetic energy. The second one is potential energy. Kinetic energy is related to associated with moving objects. Okay. Let's see in a simple example. Consider where we have an object with mass m and with velocity v. It moves to the right, okay? And this is ground. Since the object has velocity v, we can write its kinetic energy in terms of velocity and mass like this. Ka equals 1 over 2 mv squared. Okay. Think that you are very hungry, okay, and you have no energy. And when I say, let's go to run in the campus, okay, probably you say, oh my God, I feel very bad, I feel dizzy, so I have no energy. But when you drink an energy drink or eat something, you gain energy and you say, let's go to run. And the more energy means the more velocity you have. Okay? This is a good analogy. Okay, kinetic energy is directly proportional to velocity squared. Okay, what about potential energy? Do you have an idea? Potential energy. What is the difference between kinetic energy and potential energy?
Energy of staying object, not moving.
Right, right, okay. Potential energy is related to height of an object from the ground, okay? Let me show it. Consider this is ground and your object M is away from ground, let's say h. H is denoted by height denoted by h. Okay? So your potential energy can be written as like this. Pa equals mgh. Here m is mass of the object, g is the gravitational acceleration of the earth, and h is the distance. So to understand the potential energy, I can give an example. Consider, why don't you die when you fall from an armchair to the ground, but you die if you fall down from the top of Empire State? Why? Because of height. Okay. Now to understand conservation of energy, let's put these two examples into one. Okay. This is again ground. This is your mass. This is your initial velocity. Okay. Think that you throw the ball up with constant velocity v. Okay. At first time, you know, from this equation, you have your mass has a kinetic energy because you have initial velocity. How about potential energy? Potential energy is zero because you have the distance between ground and the object is zero. It is automatically zero. So when this object reaches its maximum height, when it reaches its maximum height, it stops for a moment. So you can say that there is no velocity and automatically you have no kinetic energy, but you have potential energy. As a result, we can say that the total energy is a conserved quantity. Huh? And we can also say that we can find an answer to the question, why don't you die when you fall down from armchair, but you fall from the Empire State, the top of the Empire State? Because the more potential energy means more kinetic energy. Okay? More kinetic energy means what? More crash velocity. Okay? When you fall down from the top of Empire State, you have more potential energy, and your potential energy turns into more kinetic energy. More kinetic energy means more velocity. When you hit the ground, you hit the ground with very, very huge velocity, crash velocity. Okay? Any questions?
What is the exact definition of energy?
It's a big question. Okay, I will explain it in the next lecture because we have no time to explain in this lecture. Okay.